So, hi, my name is Anna Reznikov. I'm a developer on Cloudband Nokia on Vitrage team. Here with me is Dr. Liat Pele. She's leading the integration between Kubernetes and some of our products in Cloudband. So today we will discuss Proactive RCA, which is root cause analysis, with Vitrage, Kubernetes, Zabbix, and Prometheus. So our agenda for today is we will discuss a little bit reactive against proactive RCA in monitoring. Then we will discuss what is Vitrage basically, for which of you who are not familiar with Vitrage. We'll discuss why Vitrage is good for the purpose of proactive RCA and monitoring. And then we will discuss newly added data source to Vitrage, which are Kubernetes and Prometheus. Then we will see a demo, included Kubernetes and Prometheus, and also Zabbix. Afterwards, we will see other ways of using Vitrage in order to perform some proactive RCA and monitoring. And in the end, we will discuss our future plans. One of them are Beleb's algorithm. So unfortunately, Dr. Gil Eisinger from Beleb's couldn't be here because of personal reasons, but you will have his mail and you're more than welcome to approach him and he will answer your questions. So let's start. First, we will talk about the reactive and proactive monitoring in RCA. So in the reactive world, we just basically react to things that occur in our system. If there is a failure or something, then the system manager or the support will handle it. But it's basically too late. The application has already been affected usually, and the user can feel something is wrong. So we are not preventing errors from happening. Errors are happening in the system, and it's basically because we don't use correlation in the stage of warnings and predictive errors. We just wait errors to occur. In the other hand, in the proactive world, we want to prevent this failure from happening. So we don't want the failure to affect the users. We want the application not to be affected, and we want to prevent all the errors or some of the errors in the system. We want to prevent them totally or perform some quick actions shortly after it happens so the user doesn't feel the effect. So we will do it using correlation between warnings, among other things. And also we can run diagnostic actions that will recognize some things before it went really wrong. So let's discuss a little bit Vitrage for those of you who are not familiar. So Vitrage is a project that started 2.5 years ago. It's a root cause analysis project in OpenStack. After 6 months from its start, it became an official project in OpenStack, and the first release was Neutron. In the last Queen's release, we had close to 10 contributors, and we're always welcoming more contributors if you are interested. So, as I said, Vitrage is the OpenStack root cause analysis project. It gives you a holistic view on your system. It has a topology graph that describes all the resources in your system, and also it has a view of the alarms in the system. So we're organizing OpenStack alarms and events, and not only OpenStack. You can write your own data source. It's really pluggable. Very easy to write data sources and plug it into Vitrage and see your own data in Vitrage. Vitrage can also deduce alarms that haven't been received from any monitor system. And it performs root cause analysis, connects between different alarms and which alarm caused which alarm. And we can also pass information from Vitrage to other services. Recently, we also added a webhook component, so anyone can subscribe to HTTP notifies and get data from Vitrage. What is basically in Vitrage UI and the API? So we have the entity graph, as I mentioned. It's a graph of all the entities in your cloud, and it also contains the alarms in the system. We have the topology graph that helps you to focus on the failure resources in your system. And we have the visualized RCA, the connection between alarms and the analysis of which alarm caused which alarm in the system. So how can we use Vitrage for doing proactive root cause analysis based on what we saw Vitrage can do? So Vitrage can have decisions based on information from different data sources and based on the entities we have in our graph. So we can correlate between the structure of the cloud and the different alarms and have better decisions on our system. And also we can monitor different layers of the system and get all the alarms in the same place. And also we can make decisions based on RCA of the alarms. So the decisions we can make is changing states of resources, deducing alarms, and cause actions, corrective actions, or diagnostic actions in the near future. So an example for the corrective actions we can have is Mistral workflows. We have Mistral notifier already implemented in Vitrage. So if something goes wrong with our system, like for example, we see alarm on the compute and it causes alarms on the VMs, and Vitrage can recognize these connections between the alarm on the host and the alarms on the VMs, and then we can execute auto evacuation and move those VMs to another host that is not affected by any alarm. Furthermore, we can use the capabilities of monitoring systems like Zabbix and Prometheus and other more that have features of predictive actions. So both Zabbix and Prometheus have predictive alarms that is based on linear regression, and we can use it also in Vitrage. And you can see it in the demo in a few slides. Furthermore, we have executing diagnostic actions. We will have it very soon in Vitrage. There are some expensive tests that we don't want to run periodically. So like, for example, if we have degradation in memory access, so we might want to do some memory scan automatically, and we want to do it only on demand because it's really expensive for the system. Additionally, we want to run on-demand diagnostics. Even if we do perform some tests periodically, but we're doing it only every 10 minutes or 5 minutes, sometimes we would like to do it on demand in this particular moment. So we want to add this functionality to Vitrage, and we will discuss and see little example by the end of the presentation. So now we will discuss the newly added data sources to Vitrage, and Liat will do it.
Hello. Okay, so containers and Dockers, I'm sure most of you familiar with this subject, but I would like just a line. In the last years, containers and particularly Dockers become very, very popular. Docker are another virtual layer like VM between the host and the application. Unlike VM, Docker use the host OS system. Docker are much more lightweighted, and they enable the developer to develop on their computer, wrap it in a Docker, and flew it to the cluster. Kubernetes is orchestration for containers. When we move to large scales, in most systems, most people find that they need orchestration. According to Datadog, order of 80% will use Kubernetes to orchestrate their Docker. Kubernetes enable to scale up the Dockers to deploy, and if we have a container fault, it will restart it. Just for the terminology, Kubernetes has nodes. Nodes can be either VM or bare metal. In this node runs pods that contains several or one container. It can be different architecture for Kubernetes setups. For example, we can run containers over bare metal, like here, or we can run containers over VM that are over bare metal. There is advantage and disadvantage to each architecture. For example, in performance, in footprint, or in if we want, for example, GPUs, then bare metal can be more useful. Prometheus is a monitoring system. Around 60% of Kubernetes users use Prometheus for monitoring their Kubernetes. It has effective database, a flexible query language. It has alerting system. And I think one of its most strengths is that it has a pluggable for different exporters. So exporter is like an engine. So almost every monitoring system can implement exporter, and therefore Prometheus has many integration with other monitoring systems. On the other side, Prometheus can send alarm in different formats. Okay. Demo. So in our demo, we are going to cause CPU stress in the host. And two things is going to happen. One is that Zabbix will predict alarm with high CPU. This alarm is that the CPU load is growing, is building. It will use a linear regression to see that the CPU load is growing. And in this demo, we will monitor the service on the pod, and we will see that we have a degradation in the performance. So Zabbix will send alarm on high CPU, and Prometheus will send alarm of performance degradation on the VM. Vitrage will know that we have two kinds of alarm that connect to each other, and will deduce a new alarm that is alarm on the host. Okay. Okay, so here is our system. Here is all the VM in our setup. And this is the network ports, and these are the networks. Those VMs is part of Kubernetes cluster. They all sit on the same OVS compute, and this is a VM that is not part of Kubernetes setup. Here we can have a look at the Kubernetes dashboard, and we can see that we have several pods running, and one pod is mainly of our interest. We called it number cruncher. This pod does some kind of number crunching, and we are very interested in its performance. We can see that it's mainly CPU bounded. So we added a Prometheus client to monitor its performance. It has some loop that's going around, and we measure how much each loop duration takes. And we can see that here it's pretty stable. We monitor with Zabbix the host as well. And we see that until now, everything is pretty clear. Now we are going to mess up the setup. I'm adding a CPU, but before I will do it, I will have a look at the top. And we can see that the load average is less than 4. That is a pretty good load average, considering that this setup has around 23 CPUs. It's low number. And that most of the CPU goes to the KVM. Now I'm adding CPU stress, and we can see the new stress processes in the system. And we can see that the low average is building up. Processors is standing in the line before they can get CPU. So that's why we have this load average building up. Let's have a look how our pod doing. And we can see that it perform decreases. This is a time duration of the loop, so high number is bad. But if we just had a look at the Kubernetes, we won't see a really dramatic change. It's like we stealing CPU from the pod and from the VM. The pod doesn't know that it has less CPU. If we look at Zabbix, we have a new warning that says that we predict CPU load on this OVS. It's still not critical. We just Zabbix sees that the load average become bigger and bigger. At Vitrage, we have the two alerts together. One is of the predicted CPU, and the other is degradation of the performance. And Vitrage deduce a new alarm that is host performance damage. It's not enough that we know that the host is doing not so very well, but now we can see that it actually affects the performance of the system. Here is we can see that Vitrage, again, from those two alarms, produce a new alarm that is host performance degradation. So if I'm an administrator and I know something is, well, not so good in my host, but I would like to know what I should do with it. Should I buy a new host? Should I kill some of my posts? Does I need to do anything? Maybe it's nothing. Maybe it's not a fact. So this way, I can now tell that there is problem in the host, and this problem affects my performance. Anna, I think. So Anna will go on.
Thank you, Liat. So let's discuss what else we can do with Vitrage. As Liat showed to you in this demo, we only produced deduced alarm in Vitrage. But as I said earlier, we also could execute actions in Mistral and also notify other services or other systems of the things that happened in our system. What you saw in the demo, it's just one of the things you can do with Vitrage. Furthermore, you can also use prediction functions in Prometheus. We saw already in the demo the predictive capabilities of Zabbix, but Prometheus also have it, and we can pass alarms, predictive alarms to Vitrage from Prometheus also. As I mentioned before, the data sources are pluggable very easily to Vitrage. So if you want to use Vitrage, you can do it with any monitoring system. You just need to invest in it like 2 or 3 weeks of development, and you can use Vitrage very easily. And if you use one of the data sources that are already supported, so it's very easily. We support collect D alarms, AODH, Zabbix, Prometheus, and we will do more in the future. Furthermore, we combine data from several data sources, as you could see in the demo. So it gives Vitrage a chance to have a more smart view of the system and also better decision making. And also it is very convenient for the system administrator that doesn't have to look at all monitoring system all the time. So let's discuss a little bit of future plans. So this is the near future plans, and not so far away. So first one is diagnostic actions. As I described before, it's something that is very important because we have sometimes very expensive diagnostic actions we want to perform, or we want to perform diagnostic actions on demand. So for example, if you have an alarm on your VMs, you may suspect that something on the host is not good also. So you might want to perform a diagnostic action and then have the answers back into Vitrage and also raise the alarm, the relevant alarm that you discover, and connect it to the other alarm that caused you to do this diagnostic action. So I think it will be something that will help a lot of use cases. The next plan for the future is the Bellab's algorithm for change detection. So as I said before, this algorithm was developed by Bell Labs in Nokia, Dr. Gil Eisinger, who couldn't be here, and this is his email. So if you are interested in it, you can approach him directly. So I'll describe the algorithm. The background of this algorithm is that in OpenStack, we have lots of different services, and each of one has his own log file, and it is very hard sometimes to find some error or some fault in the system. You have to go through many logs and search for it, and even if you're using some tools for log analysis, it's also not always easy. If you don't use some smart log analyzer, so it's really almost impossible to detect a fault before it happens. And even after it, it's also difficult. So the challenge is to find the root cause analysis of a problem and to notify problem even maybe before it gone very wrong in the system. And we want to do it based on log change detection. So the idea behind the algorithm is that when when there is something wrong with the system, the log behavior is different. Here we talk about the amount of logs. So when when something is wrong in the system, the logs amount will grow, or we can see the amount of logs is not stable. And also, maybe we can see that nothing is written into a log file because of connectivity issue or something like this, or the system is down. So the way that this algorithm works is it has two windows. One is a large window, and one is a smaller window of 30 minutes. And we want to compare between the amount of logs and its behavior between the two windows. So we calculated the standard deviation of the big window of 24 hours and the standard deviation of the amount of the logs in the smaller window, and then we correlate between them. So for example, we took here keystone logs. In the first graph, you can see the amount of logs over time, and the two other graphs are the ratio between the standard deviation of the amount of the logs in the small window and in the large window. The first graph is the standard deviation of the small window divided by the big window, and the lower graph is the other way around. So where the red arrow is, we can see something is starting to going wrong with our system, because we can see the fluctuation of logs is changing. So you can see at the second graph that the algorithm has detected a change in the behavior, and we could produce alarm on it and notify Vitrage about it. Now we haven't implemented it yet, but it's in our plans to the future. And also you can see that when things going back to normal, so we have another change in the deviation of the amount of the log. And then the second graph, you can see the detection of it in the algorithm. So we can, in that way, we can notify Vitrage that everything is back to normal and the system is in good shape. So this is only example on keystone logs, but we can do it on many kinds of logs. And this is example of the implementation of the algorithm on logs, but you also can use it with different data also. So that's it for us. If you have any questions, we will be glad to answer.
Please have questions.
Thank you for your talk. I've got a question about Prometheus support. As you know from the sources, Prometheus patch is not merged yet. So are you going to release it in Rocky timeframe?
I think so, right? Yes. Yes, Prometheus will be integrated in
the Rocky version.
Rocky.
Oh, great. And will it work without Kubernetes?
Again?
Because we use Prometheus for OpenStack monitoring.
He's asking if we use Prometheus for other things and not only Kubernetes.
For now, we use Prometheus only for Kubernetes, but in moment things are attached, you can set your Prometheus to monitor whatever you like. Monitors has, I think, tens of exporters, and everything will be in its place.
Yeah, it doesn't make a difference what we are using Prometheus for in Nokia, because once we have the data source, you can send to it everything you want.
So particularly we use Zabbix for the host, but it can be Prometheus as well.
Okay, thank you.
You're welcome.
Thank you.
Hi.
Hi.
We run a lot of media workloads on our OpenStack, particularly online video. With that last algorithm, would you start to see false positives when we get very burstable traffic, particularly if there's like a sports game on, or if it's a rainy Sunday and everyone wants to watch video online?
Well, note that this algorithm is mainly on the standard deviation.
Yep.
So if you have like a load, then you expect to see everything on the load. So the average will be high, but not particularly the standard deviation. So I don't think that having load will be so much change, but you might need to check it, of course, because it's a preliminary result, not preliminary, but it was not tested on production yet. So, but I would guess that it will work for you because it's not checking not the load average and just the logs. And if it's high and stable, then it's the same standard deviation.
But you are more than welcome to approach Gil from Bell Labs, and he can help you more even.
Okay, thanks.
Thank you.
So I had a question about the algorithm. Is that purely looking at the essentially the number of lines in the log? It's completely content agnostic.
Yes.
Okay. Do you know if, I'm sorry, I know it's the gentleman who's not here, but do you know if there's any plans to kind of make it more content aware or do some sort of like duplicate filtering or anything kind of further along those lines?
Yes. The team of Bell Labs that sitting with us at Israel in near Cloudband, they started to build an algorithm for logs analysis. So they are studying the field now, so if you have an idea, so you're more than welcome to approach the guys from Bell Labs and have a discussion about it.
Okay, thank you. Thank you for the talk.
Thank you.
Hi. When you have things moving around in an environment, like you need to live migrate a system to relieve a CPU overload, does that cause ramifications for Vitrage itself as far as recalculating its dependency trees?
Vitrage is getting its data sources notifications and process it relatively fast, so it shouldn't affect us so much. But if you affect the VM that Vitrage is running on, so it might have a problem, but now in a Rocky release, we will have HA supported, so it shouldn't affect us very much.
I don't think it will affect us at all, because Vitrage in the computes, it's...
Yeah, I mean more like the calculations around figuring out which VMs are on which physical hosts or which storage.
It shouldn't be affected because the graph is changing every time, and Vitrage knows the topology every time it's updated. So all the calculations are based on the current graph, so it shouldn't be affected.
Okay, thank you.
Yes, it dynamically changed, sure.
Thank you. Any more questions?
Currently, we are managing the virtual machines using the VMware as well as OpenStack, so and monitoring it by Zabbix. So I want to know that can we use Vitrage in case of VMware for monitoring the VMs?
I don't know if we tested it yet.
We didn't. Well, if
no, but we have decoupled Vitrage from the, previously it could run only on the OpenStack system, but we have decoupled it, so it should work. And if you want to do it, you are welcome to talk with us, to contact us. I'm sorry I didn't put our contact details, but you can find us on Google or approach me after the lecture, and we can help you with this.
Yeah. More questions?
Okay. Thank you very much.
Thank you.